All right, welcome back, 8th graders. We're going to do example 2 out of your 4.5 packet today. On example 1, we identified direct variations from equations. So that was a skill you learned in the last video. Go ahead and flip to your next page, and we're going to start preparing for example 2. And the very first question I wanted to ask you is, what happens if you solve the equation y equals kx? What if you solved it for k and just got k by itself? All right, so that's our goal. So let me show you over here what that would look like. First of all, what operation is going on between the k and the x? Now, if you said multiplication, you're absolutely correct. How do you undo multiplication? Yes, division. So we're going to divide each side by x. Now see on the right, all the x's, both x's will cancel out. And on the left, we have y over x is equal to k. So now another tool in your arsenal about direct variation is you now know how to calculate the constant of variation for a direct variation. So if you look down here, I gave you a little statement. I said, so in a direct variation, the ratio y over x is equal to the constant of variation. Another way to identify a direct variation is to check and see whether the y divided by x is the same number for each ordered pair. Now that works except where x is 0. Now if you remember, I'm going to have you on the side. Why, I want you to answer this question. Why can't x equal 0? What's the big deal about that? If you can answer that question, I'll give you a bonus point. Now I'm going to need somebody to remind me that I did that, because I'm doing this video days in advance. I won't remember. So one of my students, you remind me that I am asking you that question and that this is a bonus, okay? And in fact, write that down the side. So when I check your notes, I'll see that and go, oh yeah, I need to put that on your bonus log, okay? So why can't x equal 0? What's the big deal about that, okay? You write your answer and then let me know. Now flip to the next page, example 2, identifying direct variations from ordered pairs. And what we're going to do is we're going to tell whether each relationship is a direct variation or not, and we're going to explain ourselves. Now, as you notice, you know me, I like to give a couple of ways to find this. So we're going to do method 1, we're also going to do method 2. Method 1 is where we're going to write an equation from the given table. You have already done this. This is a skill you already know how to do. We did that a couple chapters ago. So remember, ask yourself, what is happening to x? Or what am I doing to the x so that I get the y? So what are you doing to the x that will give you that y? So for example, what are some ways you can go from 1 to 6? What did you do to the 1 to possibly get 6? Now if you said, oh, I added 5. Well, yeah, that's true. 1 plus 5 is 6, but what's 3 plus 5? Well, it's not 18, so that's not going to work for us, okay? So addition is not the answer here. What's another way you can get from 1 to 6? If you said multiply by 6, I think we should investigate that further. So let's see if that pattern is consistent on this table. So we see that 1 times 6 equals 6, 3 times 6 is 18, and 5 times 6 is 30. So my equation would then be y equals 6 times x. I'm multiplying the x by 6 to get the y. That's how I came up with my equation. Now, I have to see whether this is a direct variation, so I'm going to put my direct variation equation right underneath it. And everything matches up perfectly. The y, the equal sign, the 6 is over the k, x is over x, and it is definitely a direct variation. So, definitely so. So you could do it that way. You could actually create an equation and just match it up and see if it matches the y equals kx equation. That's not my first choice, but it may be yours. Actually, method 2 is my first choice on the table. What you would do is you would find y over x for each ordered pair. So your first ordered pair is 1, 6. So remember, the first number is x, second number is y, and you would do y over x. Okay, well 6 over 1 is 6. Here's your second ordered pair, 3, 18. First number is x, second number is y. So remember, y over x. And 18 divided by 3 is also 6. And then your third ordered pair is 5, 30. Now 5 is x, 30 is y. Remember, we're doing y over x. And 30 divided by 5 is 6. Notice they all equal the same number. They all have the same ratio of 6. Y over x in each ordered pair is 6. This is a direct variation. Now, if those numbers were different, let's say you got a 6 and that was a 2 and that one was a 5, they were all different, that's not a direct variation. A direct variation means all 3 points on your table have the same ratio y over x, and that's what makes it a direct variation. So there's 2 ways here now that you can tell whether a table of points is a direct variation or not. You can do the equation, you know how to do that, or you can just do the y over x. Whatever makes you happy, makes me happy. All right, let's try letter B. So here's our second table. We could do the equation. So what did we do to x to get y? And so kind of mull it over in your mind. You could say, hey, I multiplied 2 by -1. Now that's a possibility. 2 times -1 does equal -2. But does it work in each of the other points? What's 4 times -1? Well, I'm sorry, that's not -4, that's actually 0. So multiplying is not our option here. We did not multiply by -1. Now let's try another option. Could you have possibly subtracted 4? So let's try that out. 2 minus 4. Yeah, that's -2. What's 4 minus 4? Yep, that's 0. What's 8 minus 4? Yeah, that's 4. So it works. The pattern works. It's a subtraction pattern. Now let's line it up and let's see if it's a direct variation. We have a problem here. You have this constant number hanging off the end right behind x. And in a constant direct variation, we don't have an extra number hanging off behind the x. So this is not a direct variation. Okay? So you can use the equation to figure out whether it's a direct variation or not. Now my favorite way is to do y over x. So here's our first point, 2, -2. And you just do y over x. And there's my first ratio is, of course, -1. Our next point is 4, 0. So let's do y over x. Now, I already can see we have a problem. We didn't get the same ratio. I got -1 in the first one and 0 in the second one. And if you do the third one, you'll see the point 84 is 4 over 8, which is a half. They're all different. This is not a direct variation. Okay, so I tried to show you an example of one that is a direct variation, and that's letter A. We did the equation, we did the y over x and compared the ratios, and then I showed you one where it's not a direct variation in B. So hopefully that helped. If you have any further questions, come to class with your questions.